Okay, we're back. We're going to start looking at some examples. Okay, here's our function in question, rational function, 2x minus 2 over x plus 1. And where do you think we're going to ask the question as to the limit? Well, most likely at -1, where the function's undefined. Okay, so, all right, let's see the questions that are asked. Determine each limit. Okay, well, here comes an infinite limit. In the previous video, we spoke of infinite limits previously, okay, as the end behavior. What's happening as the function moves towards infinity, either positive or negative infinity, okay? For a function 2x minus 2 over x plus 1, we should recall our horizontal asymptote, being the ratio of the highest powers top and bottom, is y equals 2. So in the long run, we have an end behavior of y equaling 2. The function is moving towards y equals 2. So as we move towards infinity, or as we ask the question, what is the limit as x goes to infinity? Okay, we're going to conclude that it is 2. And again, we can approach infinity, okay, from the left side. We can't come from the right side of positive infinity and ask the question. It just does not make sense, okay? Next question. What is the limit as x approaches negative infinity? Well, again, rational functions, limits going towards infinity are asking the end behavior. Limits going towards infinity are asking the end behavior regardless the function. Okay? Limits moving towards infinity or negative infinity are asking the end behavior of the function. In our case here, we're talking about rational functions in which we have a end behavior characterized by an asymptote, specifically the asymptote y equaling 2. So therefore, the question, what is the limit as x approaches negative infinity, is going to be just that, 2. What is the limit as x approaches 1 from the left, approaches -1 from the left side? Graphically, approaching 1 from the left is moving towards positive infinity. Okay, so the one-sided limit approaching -1 is positive infinity. The one-sided limit approaching -1 from the right, owing to the asymptotic behavior at x equaling -1, the limit as x approaches -1 from the right side is negative infinity. What is the limit as x approaches -1? Well, the left and the right side are moving in different directions. They are not in agreement. The limit as x approaches -1 does not exist. Again, because previously it was determined the right-hand limit is negative infinity, the left-hand limit is infinity. Therefore, the limit approaching that value itself does not exist. Let's look at some other, okay, infinite limits. And these, as all infinite limits are asking, is asking for the end behavior of the function. The end behavior of the function, okay? So, polynomial functions have either both ends rising, both ends falling, one rising in one direction, one falling in another direction. You should recall, okay, the polynomial function, the cubic polynomial function, following the arrow here, okay, all right, would have this kind of behavior, okay? Rising on the right, so the limit as you approach positive infinity is infinity, falling on the left, okay? So therefore, the limit approaching negative infinity is negative infinity. Again, I'm only asking, when asking the limit as x approaches infinity, positive or negative, is asking the end behavior question. Okay, a polynomial function of an even variety has both ends rising when the leadoff coefficient is positive. Since the leadoff coefficient is negative, both ends are falling, implying the limit moving towards negative infinity is negative infinity. The limit moving towards positive infinity is negative infinity. The rational function defined here, the limit approaching negative infinity, the limit approaching positive infinity, is asking the question of the end behavior. The end behavior for this rational function, highest power is the same in both the top and bottom, is indicative of, okay, a ratio of 2x to x, which is y equals 2, which is in fact the asymptote, which is in fact the limit approaching negative infinity and approaching positive infinity. Rational function 7 over x to the 22nd power, bottom heavy, bottom heavy. That means the asymptote is riding along the x-axis. Riding along the x-axis is the y value equaling 0, to imply that the limit as we move towards infinity, both from the positive and the negative, is going to be 0. E to the negative x. E to the negative x. The difference between e to the x, let's follow the cursor here, e to the negative x is the reflection across the y-axis, okay? Should agree. Approaching negative infinity is approaching infinity. As we approach positive infinity, e to the negative x heads for the x-axis as its asymptote, and therefore the limit as x approaches infinity is 0. Sine of x. Sine of x is always oscillating between 1 and negative 1. Forever and ever and ever, okay? It is never settling in on any value, has no asymptote, it's continually oscillating. There is no limit. As x approaches infinity or negative infinity, it's continually oscillating and never settling in on any definitive value. Inverse tan of x. You need to depict the picture, okay? The inverse tan of x, okay, has a domain covering all values of x, but a range restricted between negative pi over 2 and positive pi over 2. So we have one asymptote as we move towards negative infinity, which is negative pi over 2. We have another asymptote moving towards positive infinity, mainly pi over 2. So therefore, for the function f of x equaling the inverse tan of x, the limit approaching negative infinity is negative pi over 2. The limit approaching positive infinity is pi over 2. There again, question of the limit as x approaches infinity, either positively or negatively, is asking as to the end behavior of the function. Polynomial functions rise or fall on one end or the other. Rational functions, okay, will look for a horizontal asymptote. However, a rational function, which is top heavy, if you will, perhaps if we've reciprocated this x over x squared plus 1, then we would have a slant asymptote, in which case our rational function would have end behavior of moving towards positive infinity or negative infinity, depending upon the direction. Okay, so we'll end that video here and come back with further discussion on this PowerPoint.